Hello everyone, welcome to Engineering Explained channel. In this session, I am going to take Basic Thermodynamics Model 3, Lecture 4, that is heat pump. The heat pump is the device which pumps the heat from the lower temperature reservoir to the higher temperature reservoir, or from cold reservoir to the hot reservoir, and that is possible when the input work is required to that. That is, the usually the heat will transfer from the higher temperature reservoir to the lower temperature reservoir, and reverse is possible by input work. That is, this is reverse of that of the heat engine. And in this one, heat pump, the same cycle we are going to use, and the refrigerator also we are going to use the same cycle. The output what it is required, based on that we are going to classify as the heat pump or a refrigerator. Here the output required is the hot reservoir temperature, then we are going to call it as a heat pump. If the output is the cold reservoir temperature is important, then we are going to call it as a refrigerator cycle. Okay, here details of working of this heat pump I am going to take here. That is in line with that of the refrigerator cycle also. The comparison we can take here by discussion. A heat pump works by using the vapor compression cycle to transfer heat from a cold reservoir to a hot reservoir, powered by external mechanical work, effectively acting as a reverse heat engine. It is the reverse of the heat engine. The cycle involves a refrigerant that evaporates in a cold heat exchanger. Okay, that refrigerant evaporate in the cold heat exchanger, that is called a evaporator, and is compressed to a higher temperature and condenses by releasing heat into in a hot heat reservoir, that is called as a condenser, that will condenses in a hot heat reservoir where it releases the heat and then expands through a expansion valve, returning to the evaporator to repeat the process. Okay, here by this animation how the heat pump works we can see. This is the evaporator, that is a heat exchanger actually, and due to the low pressure and low temperature of the refrigerant, it will receive the heat from the outside environment here, and that will be get evaporated. That means the q in amount of heat this refrigerant will be absorbs, and after absorbing it moves to the compressor, and where it will be compressed to a high temperature and high pressure, and after compression the refrigerant moves to the condenser. Due to the high temperature and high pressure vapor, the heat will be rejected to the outside atmosphere, and that is transfer of the heat will be taking place. And due to that condensation process, it will be condenses to a liquid refrigerant. After rejecting the heat, it will condense to a liquid refrigerant, and that liquid refrigerant will be expanded in the expansion valve. After the expansion, it will become a lower temperature liquid refrigerant that will move to the evaporator to continue or repeat the cycle. Like this, by operating in the four processes, the heat will be absorbed from the one environment, low temperature environment, and that will be transferred to the high temperature environment. Okay, that is the pumping of the heat will be taking place. That's why it is called as a heat pump. Further moving the what the components we can see here, key components and their function. A heat pump system uses a closed loop with a working fluid called a refrigerant and includes four main components. First one is a evaporator. At a low pressure, the refrigerant absorbs heat from the cold source, lower temperature source. Example, outside air. The heat is to be transferred from the outside air to the inside room, then the outside air heat will it will receive, or from the ground, and evaporates into gas. That will be evaporates into a vapor or a gas we can call. Then second one is a compressor. The gaseous refrigerant is compressed. The gaseous refrigerant is compressed, increasing its pressure and temperature. When the gaseous refrigerant that is compressed, then its pressure and temperature both will increase. Then that compressed gas will move to the condenser. The high pressure, high temperature vapor then releases heat to the warmer reservoir. That is called as a taken as a example indoor air. That means inside the room the heat is to be transferred and condenses back into a liquid. Condenses back to a liquid after releasing the heat. Then fourth one is the expansion valve. This device reduces the pressure of the liquid refrigerant, causing it to become a cold, low pressure liquid, which then returns to the evaporator to repeat the cycle. Hereby, the four processes, the heat will be transferred from the low temperature reservoir to the high temperature reservoir. Usually, in the colder regions where the room is to be heated, the heat pump is used for the heating of the room, keeping the higher temperature inside the room. There we are going to use the heat pump, or sometimes to heat the water. To heat the water, we are going to use the heat pump. Okay, similar to that solar water heater, we are going to heat the water by using the this heat pump also. Further, moving that one in this thermodynamic principle, what is used in this heat pump? Heat transfer against the natural flow. Naturally, we know that heat will be transferred from high temperature reservoir to the low temperature reservoir. By applying external work, a heat pump forces heat to move from colder region to a warmer region, which is the opposite of the spontaneous direction of heat flow. Coefficient of performance COP. The efficiency of a heat pump is measured by its COP, which is the ratio of the heat output in heating mode for the heat pump it is, or heat absorbed, that is a cooling mode for the refrigeration cycle, to the mechanical work input. The heat output to the mechanical work input is the COP of the heat pump. Heat absorbed to the mechanical work input is the COP of a refrigeration cycle. A higher COP indicates greater efficiency. In summary, the thermodynamic cycle of a heat pump efficiently transfers thermal energy by controlling the phase changes, evaporation and the condensation. By phase change controlling, the heat will be transferred from the lower temperature body to the higher temperature body of a refrigerant, using mechanical work to move heat where it is needed. This is about the how the heat pump works, and this is the according to the second law of the thermodynamics, where it is not possible to transfer the heat from the low temperature body to the higher temperature body without any external work. That is the second law of the thermodynamic statement. According to that, this heat pump works. And further, I am going to take the efficiency of the heat engine and COP of heat pump and the refrigerator in the further sessions. Thanks for watching. If you like, share, subscribe, and comment.